This episode of Mathematics with Mr. Richardson is brought to you by Slinky.
Who walks the stair without a care and makes the happiest sound? Bounce up and down just like a clown. Everyone knows it's Slinky.
Welcome to Section 9.1, Mathematical Patterns. Objectives of this section: to identify mathematical patterns found in a sequence, and to use a formula to find the nth term of a sequence. Lesson vocabulary: sequence, term of a sequence, explicit formula, and recursive formula. An essential understanding: if the numbers in a list follow a pattern, you may be able to relate each number in the list to its numerical position in the list with a rule. Consider this. For each figure, how is the number on the center tile related to the numbers on the other tiles? What will be the center number in figure 6, in figure 10, in figure N? Explain your reasoning. Well, it seems pretty intuitive. In figure 1, 4 represents the sum of the 4 1 squares around it. Moving on to figure 2, checking a similar rule, 12 represents the sum of the squares around it. And figure 4, well, 40, rather than counting up all of the tiles, maybe we can find a new pattern or technique here. So let's count one of these diagonal trails. Consider this explanation of 24, which we can derive from figure 3. 24 does equal 4 times 1 plus 4 times 2 plus 4 times 3. Notice also the right-hand side of this equation can be rewritten using the distributive property as 4 times 1 plus 2 plus 3. Notice this is figure 3, and notice that increasing sum, 1 plus 2 plus 3, ends at 3. This should give us a good enough pattern from which to derive the values of figure 6, of figure 10, and then of figure n, where n is any value. Extending this pattern, we can understand that figure 5 would add 4 5 tiles, or tiles with 5 marked on them. And 4 5 tiles would have a sum of 20. 20 plus 40 is 60. Figure 6 would add 4 6 tiles. 4 times 6 is 24. 24 plus 60, 84. The same logic can be applied to derive figures 7, 8, 9, and 10, but let's extend that reasoning to derive an equation to represent the sum in figure n. So if we want to derive a formula to find the sum or the center tile's value for a figure n, some arbitrary number n, well, this would be a good approach. We know that our sum will be 4 times the sum of the trailing diagonal tiles. And those tiles will be represented by a 1, a 2, a 3, etc., until finally reaching whatever number we've chosen for n. Now notice the sum within the parentheses can be rewritten as the average of all of those individual values times the number of values there. So to find the average, or the mean value of these numbers inside the parentheses, we can take the smallest value and the greatest, and divide by 2. Now may be a good opportunity to pause and reflect upon that concept. How 1 plus n divided by 2 will represent the average of the values within our parentheses. But our goal is not just to find the average value. We want to represent the sum of all of the values. Knowing the average, to find the sum, we now just need to multiply by the number of terms within the parentheses, n. I'll multiply by n on the right to help keep from confusing the n on the right times the 4 on the left. And now I'm going to get crazy and distribute both the n and the 4 in one step. Next, I'll reduce the fraction, noting that 2 is a common factor between all 3 terms. I'll also rewrite in standard form. And finally, factor out a greatest common factor of 2n. And we're left with a formula that will find the sum for us of the nth figure.